In this video, I'm going to talk to you about the idea of rebalancing your portfolio, and I'm going to show you Python code which will allow you to automatically rebalance your portfolio according to an optimization algorithm that I will describe to you. First, let's discuss the idea of rebalancing. What is rebalancing? If you are investing your money with a money manager, it is likely that he's spending most of his time rebalancing your portfolio at a periodic basis. Rebalancing your portfolio simply means that if you hold this basket of stocks, for example, how do you periodically assign how many of each stock to hold, or what percentage of each to hold in your basket of portfolio? This is different from indexing. Simplest method of investing is indexing. It cannot get any simpler than indexing. When you are indexing, you are holding a ETF which basically follows the S&P 500. In this case, I'm holding VOO, which is the Vanguard ETF, which follows the S&P 500. And then you simply do nothing. You just lazily sit around and let the ETF do its job. Now, if you look at the Vanguard S&P 500 ETF, you will observe, if you sort of scroll down the ETF itself, you'll observe that it consists of a number of stocks, and the ETF itself basically goes through some rebalancing which is done by the advisors in Vanguard. And you can see the individual stocks and how much percentage of the fund is constructed by each of these stocks here. But rebalancing is trying to do this in a more manual way. So here we take a few different stocks. We could have taken individual stocks, but we decide to take Vanguard sector ETFs. These are ETFs which represents sort of a combination of stocks in each of these sectors. For example, VDE represents a combination of stocks in the energy sector. We can look at the Vanguard energy ETF and we can see that it's composed of these stocks in the energy sector, such as ExxonMobil, Chevron, ConocoPhillips, and so on. These sort of the more usual names. We can start with this. We can start with 3 of these stocks as our basket of stocks, just to make things easier. And then we can see how rebalancing works. So let's say we are in the first month and we don't have any knowledge of the returns of these stocks. So we distribute the money equally between these stocks. So 33% of our money is in VGT, 33% in VDU, and 33% in VPU. Now we go to our second month. We observe the returns for each of these stocks. We observe that VGT has gained a 50% return. This is just an example here. In this 1 month, VDE, which is the energy ETF, has got 25% returns, and VPU, the utilities ETF, has got 25% returns. What we are going to do now in the second month is that we're going to take this basket of stocks and we are going to assign more stocks to we're going to assign a higher percentage to the stock that got higher returns. So we are going to proportionally divide up based on the returns of each of these stocks. So because this VGT has got double returns compared to the VDE and the VPU, we are going to assign 2x more shares to the VGT. So 50% of our shares will go to the VGT, and the rest will equally be divided between VDE and VPU, which have got equal returns. Now we come to the returns for the second month. And we observed that in the second month, all of these stocks did equally well. None of them exceeded the other in their returns. So what are we going to do? We are again going to come back in the third month and rebalance the portfolio by constructing it exactly similar to what we had in the first month, which is exactly equal number of stocks for each of these ETFs. And this is the idea of rebalancing. Every month we observe the returns, and our hope is that the winner is going to have a momentum. And based on that, we assign more stocks in our portfolio to the winner. So we sell all the stocks and then we buy back the stocks. But when we buy back the stocks, we are going to change the proportion of the stocks in our basket. And and we keep on doing this for an extended period of time. And the hope is that that is able to beat the index investing, which is sort of the laziest form of investing. And now we are going to look at some Python code and some data to see if that is really true and why not. So let's look at the Python code now. So we download the data. And again, the link to the Python code will be in the description below, the link to this notebook, and you can use this notebook and do your own calculations. So we download the data, which consists of the high, low, open, and close for each of the stock symbols for over 500 stock symbols. Now we look at the sector ETFs. So these are all the sector ETFs that I gathered from Vanguard's website. This includes consumer staples, consumer discretionaries, communications, energy, financials, healthcare, industrial, and so on. And then first I want to check if these ETFs are in the data. They all have about 133 days of data for each of these ETFs. So I am assured that these ETFs are in my data so that I can sort of get the reliable daily data for these ETFs. So now I come to the meat of the code here. And this is the class that will help us rebalance our portfolio in a periodic manner, which basically we will do this monthly. Let's see how we do this rebalancing. So we initialize with the total value of the total cash and what our leftover cash is. When we have not bought any stocks, so our leftover cash is simply equal to the total cash. And now we have a list of stocks and a dictionary of stocks, which will basically tell us how many of each we are going to use. And so initially, as I said, we have the dictionary of proportions, which are going to tell us what is the proportion of each stock. And if we go back to our drawing, you will see that initially we had the exact same number of stocks for each of these ETFs because we did not know any better. And this is exactly our initialization here, where our proportion is going to be the same for each of these stocks in the given list. And the list is the list of these sector ETFs. And then finally, when we call this rebalance function, which is the main function here, we are going to look at the returns for each of these ETFs. So we are going to get the current value, which is the value today for each of these ETFs. The previous value contains a dictionary of values for the same ETFs a month ago, and then that is going to allow us to calculate this dictionary of returns, which are going to tell us what is the percentage return for each of these ETFs. Now we can do two things. We can the one nuance here is that the minimum return can be negative. In each of these cases, if you look here, we consider the minimum return to be positive to make things simpler. But in reality, the minimum return can be negative, and this is a case we might want to handle or might not want to handle, depending on this flag which considers negative. So if our minimum return is less than 0, then we just do V minus minimum return so that every number is basically positive. Or we can just ignore all the stocks which have a minimum return less than 0. So in this case, we are constructing this return pause dictionary which ignores any stock which has a return less than 0. So these are two possible ways of doing the rebalancing basically. And then once we have done this, we define a new proportion dictionary, and this proportion dictionary contains the return divided by the sum of all the returns for each of these items here. And these items may either be all of the stocks or be only the ones that have a positive return. And so this is the meat of the class. When we call this rebalance function, it is able to sort of define this proportion dict, which is exactly the same as this dictionary here, or this one, or the one here. And so once we do this, so once we do this, we can sort of distribute the money. And the way we distribute the money is basically we start with these total leftover cash as the total value, and then we decide how many of stocks we can buy for each of these stocks. And again, we cannot be exact because the number of stocks has to be a multiple of the current, the total, the amount of cash we can spend on a single stock has to be a multiple of the current value of the cash. So we cannot buy 1.5 stocks, we have to buy either one stock or two stocks. And so there will be some leftover cash, which is what we sort of take into account here. So those are the two main functions, and then we can see what happens when we actually call these functions. So here we do some sort of sanity checks where we sort of say what happens, is the symbol VOO there, and what happens if we query VOO for a specific date, and we see that we sort of get the open, high, close values. And then we take we get the price on a given date for all of the sector ETF values. At this point, let's just go through the calculation for an example here. And just to show an example, I'll just include like 2 ETFs, which will be easier to understand. And then we can sort of go back and do this for a larger number of ETFs. At this point, I'm running the example for just 2 ETFs, and you can see what happens here. So in the first month, or in the second month, in fact, we choose to put all our money on this one stock, which is VDC. And then we have this, leftover cash of almost $80. And in the second month, we choose to put 54% of our money on VDC and 45% on VCR. And in the third month, we have a different sort of proportion, and so on. And again, this is considering we have only 2 ETFs. Now I'm going to change this code, and we are going to include all of the ETFs here described in this sector ETF date. And this is going to give us a much more realistic picture of what we can do by rebalancing these stocks. So now I'm going to run this again, and it's going to take a few minutes to run. As you can see here, now it spits out a much larger number of values, which are much harder to read, but you can see that it sort of gives a 10% to VDC, 25% to VOX, 3% to VDE, and so on and so forth. And then it does a separate calculation in the second month, and then it sort of go on and keep doing that. This whole program takes about a minute to run, and now we can see what happened to the result here. And this is what we observe in the results, which are sort of underwhelming. The black line represents what will happen with the buy and hold, which is the index investing, which we described here, which we will simply take VOO and just hold it throughout. And the blue line here represents the rebalancing, which we run based on this whole basket of stocks. And for a while, the rebalancing did as well as the VOO, or the buy and hold, and then suddenly the buy and hold started doing better. So even by doing sort of more intelligent rebalancing, we were not able to beat the buy and hold. And why is that? Let's look more closely here. So we did some post hoc analysis, and you can look at the code in the notebook that I'm going to share with you. But one thing is interesting. When I looked at the returns for all of the data from the initial date, I observed that I plotted all the returns in a sorted order, and I observed that VOO actually has the third best returns among all of the sector ETFs. So the VOO is not an exact mean value of all the sector ETFs. There is some intelligent rebalancing where VOO is taking a larger portion of probably the more technology shares, which is going to give it sort of returns which are closer to these technology ETFs rather than just a mean value or an average value of all the sector ETFs. So unlike what we had assumed naively, the VOO is not sort of somewhere in the middle of the sector ETFs, but it's sort of closer to the best performing sector ETFs. The best performing two sector ETFs are VGT and VOX, which are all technology ETFs, and we can look at that. So VGT is information technology ETF, and VOX is the communications ETF, which contains a lot of tech companies. So that is basically what is happening here, and largely I think what the algorithm is doing is giving weight to VGT or VOX. So it would have been possible that if the algorithm were choosing more VGT and VOX, we would have got a final return that is greater than VOO. But why does it not happen? Here is some interesting data when I compared VOO and VGT. As you can see, VGT finally has larger returns than VOO, but it is not true at all periods of time. VGT sort of has a larger variance, and at this point, sort of VGT's returns are less than the VOO, which means that when we keep on rebalancing at each period of time, at this point, we would actually choose less of the VGT stock, which would give us lower returns, and our returns in the final sort of returns would be less than what we would have got if we had just kept investing in VOO. I think one of the big lessons to learn from this rebalancing is that it is not trivial to beat the indexing buy and hold method, even if we do intelligent rebalancing. There is rebalancing going on inside the VOO itself, and that rebalancing may be hard to beat, even if you use a money manager to manage your portfolio. I hope you learned a lot about rebalancing, and you can try out this method on your own stocks based on the code here. Thank you.